So today we will be talking about multiplexer and demultiplexer. So first, for multiplexer, it is the definition of the multiplexer is that it is a device that selects between several analog or digital input signals and forwards it to a single output line. So it will take a number of inputs and it will output a single line. So for our first example of our multiplexer circuit, we can start with the basics. We have these three pins, and we will label this as the selector, and this is the input A, and this is the input B. Now, we will use the NOT gate for our selector, and the two AND gates and the OR gate to compare those two AND gates. So first is that this selector will go through here, and this input A will go to this first AND gate, and the input of this selector pin will go to the second, as well as the input. And we will compare those two, this OR gate, and output it with a single pin. So if we analyze this, you can see that the expression is not A or S and B. Here is the table, here is the map, and here is the table for the given circuit. So here we have the input of A and B that will output a single line of X. So for our second, we can add another circuit named Mox2. We can create a new circuit just like the previous circuit, but this time we will not compare the input of A and B, but we will compare it to the AND and XNOR of A and B. So same as the last time, we have the two AND gates and the OR gate to compare these two AND gates. So first, our selector will go to the first AND, and the input of the selector will go to the second AND gate. And here the A, oh, before that, we have to give the pins label so we can know how the circuit works properly. So here we can compare the A and B, and the A or B not, or the X not. Then here it goes to the first AND and to the second AND. And lastly, we will compare these two to produce a single line of output. So if we analyze this circuit, you can see that this is the expression, and on the table you can see it is the same as the previous circuit where we have the selector and we have the inputs A and B to produce a single line of output. But the table will yield different results because the one that we are comparing here is not the A and B. Like here in the previous circuit, we only are comparing these A and B inputs, but here the input that we are comparing for the multiplexer is the A and B and the XNOR of A and B. So that's it for our multiplexer. So for our next is we will be going to our demultiplexer. The multiplexer, on the other hand, is the counterpart of the multiplexer. It is designed to switch one common input line to a several separate output line. So it's the complete opposite of the multiplexer. From the multiplexer, it goes from multiple inputs to a single line, but here in the multiplexer, we have a number of input that will lead to a greater number of output lines. So for example here, we can use the pins again for our inputs A and B and for our selector. So let's not forget to put a label on that. Then here on the multiplexer, we'll be using NOT gates for our A and B. And we will be using 4 AND gates this time for the demultiplexer. That will yield us the 4 results. So as you can see from multiplexer, we have two input and the multiplexer made it to the one single output line. And here in the multiplexer, we have a two input line and it will output a four output line. So we will be connecting that to our outputs. Put an error for now, and we will be using labels for our output WX and YZ. So first, we will connect the selector to all of our AND gates, since it will be used a lot. And then we'll connect the A input and the B input to their respective NOT gates. And we will connect it here to the X output and to the W output. And our B will be connected to our Y output and to our W output. And now from here, our A will be the raw input from A will be inputted to the last output, which is J, and also to the Y. And lastly, here is we're gonna input in to the last one to the so now we can check if our circuit is correct by always putting the selector to 1. And as you can see, the 0 is W, 1 will be X, 10 will be Y, and 11 will be Z. So if we analyze this one, you can see that this is the expression, the simplified expression. And the table, as you can see, we have here the selector, and we have the input A and B. And from the two input line, we have the four output lines that are W, X, Y, Z, and their respective um, truth table. You can also use the built-in the multiplexer gate here in the logisim and to make a new circuit. And let's first get the multiplexer. Put the selected bits into 2 so that we have the 4 output. So this will act as our select pins. And here in the select, here in the what you call this, the pin here that will be connected will be the one that will select the output. So we have to change this into 2 bits since it will be our A and B outputs. And here is our select, and here is another select. So we just put them on to 1 or on state. Then we will have our four outputs, same as before the previous circuit, and we can name them W, oh, sorry, W, X, Y, and Z. And then we can connect them one by one to their respective pins. And then if we gonna try that, as you can see on the first hand, 00 is our W, same as our previous circuit. Our 00 here is W, and here our 01 is X. Same here as our previous 01 is X, then 10 is Y, and 11 is Z. Here, using the multiplexer gate, we can use the 11 as Z and 10 as Y.